Hello everyone, and welcome to this next video discussion in the RICS Tech Partner Program. My name's Andrew Knight and I work within the standards, regulation and thought leadership part of RICS, the World Built Environment body. We have over 130,000 members worldwide, working right across the property life cycle, working within residential, commercial property, infrastructure, land. So a very broad profession with a very broad set of practice areas, and clearly the impact of data and technology is incredibly powerful and important on such a wide-ranging sector. And I'm really pleased to have Mazen from Alice Technologies to build on a discussion I had earlier with Rene to take us through the Alice technology platform in a real kind of quite detailed under the hood view of what this application of artificial intelligence can do and the value it can bring to major construction projects. So welcome, Mazen, welcome to the discussion. And my first question is always a bit of a backstory. It'd be great to hear about what your background is and what's brought you to Alice.
Awesome. Thanks for the introduction, Andrew. So my background is I guess I'll start from college, civil engineering. I've always wanted to do that so that I could eventually build and design my own house as a kid. And then as I got into the industry, I realized that the management piece, so the construction management piece, is where it really makes or breaks a project in many cases. So you might have an amazing design, but if you don't know how to build it and manage it correctly, you'll go way over budget and over schedule. So I worked as a project engineer for a bit before pursuing a master's at UC Berkeley. And I chose in construction management, and I chose that back then because UC Berkeley was the forefront of the lean construction methodology, and that was what I was most interested in at the time. And my goal was to work as a superintendent or project manager for a general contractor. Then I took an internship with a software provider, Synchro Software, that did consulting for scheduling at 4D. And my goal was to do the internship and then go back to the construction industry. But during that internship, I discovered that I was working more closely to many construction projects than I would have been if I was just stuck on one project with a traditional general contractor. So I took that route, worked on many projects, consulted for many schedules. That is me over here back then. I used to work whatever we do automatically in Alice, I used to do manually back then. I used to argue with a lot of superintendents to see what we can make work for everyone. And then I discovered Alice was automating what I was doing manually, and I really wanted to join and be on board. So I applied. I was a consultant with them for a bit and then moved into a product manager role.
Great. Well, it's fascinating to actually get under the hood on this instant, because clearly there's so much talk in the sector in various practice areas around artificial intelligence, whatever that means, and how it can actually be applied and really augment and support what we do in the built environment. So really over to you and just show us what artificial intelligence can do.
Amazing, thank you. So back to this a little bit. So what I would do back then, because these people's time is very expensive and it's very hard to get them all in the room, so they rarely have the time to give you input on the entire schedule as you're planning a project. So what you do is you ask them about a bunch of stuff and kind of recognize patterns, then do some work on your own, then bring them back together. And that's currently what people do with planning nowadays. You have these experienced planners who have accrued a lot of experience and knowledge, but still have to go to different subs and subcontractors and superintendents to figure out rules, and then they use those rules that are captured in their head to build a schedule in a table, but the table does not remember the rules anymore. And then it's maybe a good schedule that works for everyone, but then as soon as there's a change or there's a something like maybe the schedule is too long and they say, okay, what if we had 4 cranes instead of 3? They have to redo the whole process. So what Alice does differently is that rather than having someone who knows all the rules build a schedule, Alice is trying to have someone who knows the rules just put in the rules. And then the AI piece of it is what uses those rules to build a schedule. So rather than telling Alice, oh, we have to build this and then that and then this, we say that in general, the way you build a slab is you have to form, rebar, pour, cure, and strip. and then the rebar will require 1 to 2 crews and will take so much time, and then it depends on the surface area and you need so much materials and stuff like that. And then later at the end, if you want to ask a question like, what happens if I have an additional crane? Alice can rebuild many options or many scenarios just with one click of a button. So I'll demo it really quick by starting with the results first and then working our way on how we got there. Does that sound fine?
Yeah.
Amazing. So like I said, what we're trying to get to, and this may look overwhelming, so I'll just clean it up a little bit, is a place where we've set up the rules in Alice, and we'll talk about that in detail in a bit. But then we can ask Alice questions like, what if I have 3 carpenter crews, 3 steel crews, 2 surveyors, 2 concrete pumps, 6 formwork sets, etc. Alice will figure out all of the possible ways in which the project can be built using the rules I've set up earlier and the availability of resources I have now. And each of those dots is a possible way you can build the project with a time, a cost, and then some information on the key milestones. So this may be faster and cheaper than this one, but maybe I'm interested in finishing the podium sooner because I can start making money sooner, so I might take the slower one. And then each one of those dots, if you click on it, is actually a fully resource-loaded, color-coded by crew 4D schedule. So what we mean by a 4D schedule is you have the traditional Gantt on one side telling you who does what at what time, and then a visualization of that so that it's easy to see if there are any mistakes. It's easy to tie the space to the image. So I can jump to any point in time. It's like a time machine, and I can tell what's going on, what are the analytics, filtering by crew, what's the cash flow over time, what's the material usage, all of those cool things. And what's beautiful is that it exports to traditional systems like the P6 we'll talk about later.
So as you showed, it's not just about one answer. It's saying actually you have some options here, depending on what might be your most important imperative, whether that's cost or time. You can actually look at those different possibilities.
That's an amazing question. So going back to when I used to do this manually, you talk with these people and they always give you like, oh, we could do it this way or we could do it that way. And every time you have to make a decision, maybe you'll say, okay, let's analyze both ways. But then there's another decision. And you're like, okay, now I'm going to have to pick one. And then there's another decision. So by the end of making only 4 decisions, even if you've analyzed 2 cases, which most projects don't even do, you're missing out on many other options that could have been way better, because the combination of we could do this or that, let's go with this, we could do this or that, let's go with this, you make so many of those. If you're reading through this while I'm showing it, I was on a project where in one of the options, it looked good. They had committed and signed a contract for an 18-month schedule. And then when we visualized it in a video like this, they realized that the crawler cranes are not moving in time they're moving too soon to strip the formwork on a huge wastewater treatment plant. That was a $1.1 billion project. And once they corrected for that, the 18 months became 4.5 years. So they had to redo the work from scratch to figure out how they can fit. They were able to bring it down to 20 months, but it was still like they lost on this because they had already committed to 18 months duration. So to answer your question, we show you various ways in which you can build it so that we make sure you've evaluated all of the possible ways that are possible with what you currently have. And it doesn't stop here. Now is the fun part. Now is you can ask, what if I have an extra crane? What if I have an extra crew? How will this change? In traditional process, you have to redo everything. Well, you wouldn't have to redo the list of tasks, but how they connect and jump, you have to redo everything. So in Alice, I can say, okay, what if I have unlimited crews? It will give me a much faster, much shorter schedule, but it's not realistic. It will tell me what actually ended up being used. So it will tell me that you gave us infinite carpenters, I need 11. You gave us infinite concrete crews, I only need 2 because we have 2 pumps. You gave us infinite steel crews, I only need 13. So what I usually do is I'll take this data, bring it to the superintendent, and I'll show them, Alice said the best case scenario is 13. Is that possible? He might say, no, it's not, but I can do 10.
Mm.
Alice said, bring 20. Is that possible? No, it's not, but I can do 6. So we get the realistic practical maximum. So that's all of the things that are possible. And it's not always like, oh, 10, I can do 5. Sometimes it's like 5, oh, I thought we needed 7. You're telling me I only need 5? That's amazing. So we get somewhere in the middle. So we're still improving a lot, but still we can ask some questions. On one project, we got an amazing schedule, but when we looked at the concrete availability, kind of like the crawler crane case earlier, we realized that on one given day, you'd have like 200 trucks on site for that schedule. That's not realistic. So a lot of times people do these mistakes in traditional scheduling. Here, because you have the model, and we'll talk about not having model later, you can use the volumes to predict how much concrete trucks you're going to need on any given day. And guess what? You can limit that in Alice. So you can say, I only need to have 20 trucks. What is my scenario? So Alice will give you more options. You can say, what if the facade crews works on a night shift? So now you're changing the calendar. So all the concrete sub works on default, all the facade sub works on a night shift. So they don't have to compete for those tower cranes that everyone likes to compete for. So you can analyze all of these scenarios, get results, and pick which strategy works best for you. You can test different positions of the cranes. Alice will automatically recognize what elements the cranes can reach as you move them around. It's really, really amazing how you can set the rules once, ask all these questions, and even reuse those rules on other projects. So I'll stop for a bit, maybe take a question, and then
I was thinking, because it's almost, I suppose, a bit of a cliche to talk about the fact that obviously AI needs data to perform. What are the kind of basic requirements about data that a client would need to use this, both in terms of, do they need a 3D model, and also in terms of what kind of data would they need specific perhaps to the way they work or the rules that they would need to be able to train it, or is it pre-trained? How does that, what are the data issues basically?
That's a great question. It does need data. This may scare people, saying like, oh, I might not have that data, but guess what? It needs exactly the same data you would need to build a schedule the traditional way. So if you're building a schedule traditionally, you already are using that data. If you're not, then probably you're not building a schedule the right way. Sorry about saying this, but it is the same data. So what is that data? First, you need to know what you're going to build. So you might upload a 3D model and Alice knows what are you trying to build. If you don't have a 3D model, and you can kind of see at the bottom, it says 0 non-3D elements. We just released a feature. It's still not fully released, so it's not, still the usability is not amazing, but we're partially adding stuff. But that allows you to add non-3D elements and theoretically just not upload a model, just add non-3D elements and link them together. Currently, people are working around this by uploading a 3D model that represents a diagram. So they can get that done in literally a few minutes and upload this. But very soon they'll be able to just build that diagram inside of Alice. So that's the first piece. You need to know what you're trying to build. The second piece is you want to decide your level of detail. So if I look at this over here, you see all of these columns. I can individually hover over each one, or I can individually hover over each class panel. But do I want my end result to tell me build this column first, then go over here at 9:30, then at 10:45 go over here, then at 11 go over there? Or do I want Alice to tell me build zone 1, then build zone 2? Or maybe if it's a 30-year master plan, some people want the detail to be build level 1, build level 2, so not even zone, maybe even build building 1. So you need to decide what level of detail are you trying to optimize. Is it element by element, panel by panel, or is it nut and bolt by nut and bolt, very unrealistic, or is it zone by zone? By the way, the nuts and bolts can be done like we worked. I've worked before on a power plant outage where they out for like a limited number of hours, do everything, and then turn on again, and they have penalties for every delayed minute. So in that case, you might want to plan at that detail. But in general, you just want to plan by zone. So you decide that. Now, how do you decide that? It's a very easy process called auto grouping. It uses the parameters from your BIM or if you don't have a BIM, the parameters that you've input, and groups things. So I might tell Alice I want to group by level, by zone, and by type. Alice does everything for me. Or by zone, by level, and by work package, Alice does everything for me. So it's the level of detail. Then there's a semi-automated step. This applies only to 3D models, which is the detection of the physics side of it, the structural part. So when Alice is trying to build a schedule, Alice will explore the option, should I build zone A, B, and then C? Or shall I build zone B, A, and then D, or whatever? But Alice does not want to play with building level 2 before building level 1, because it's impossible. You can't have a level float. So when you click on something here, you see our engine automatically detects that you cannot build the yellow before you build the purple. You cannot build the blue before you build the yellow. So purple for previous, blue for next.
Yeah.
I said this is semi-automated because a lot of times people want to go in there and validate. They'll see like, oh, I have a constraint that's not necessarily physics, but I want to add it manually because the slipform system, I don't want them to go too high up, even though they can theoretically. I want to add these constraints. So you do that. That's step 3. And step 4 is the final step. This is the bread and butter. This is where you capture knowledge and you can reuse it. And it's so amazing. It's the recipes. The recipes can be very simple or very complicated. And the recipes describe how you build something or how you move through an area. So a very simple recipe could be these prefab sky bridges. It's just saying install these bridges. I'll talk about the details in a second. A slightly more complicated recipe could be that slab where we saw earlier. It's form, rebar, pour, cure, strip. You might have an even more complicated recipe for interiors. For example, here we didn't get all of the MEPs in because we don't need to. We just put a placeholder with custom properties explaining the quantity of duct, the quantity of piping, etc. And then in the recipe, we put all of our details. So I need the layout and top track, opens up for the gas sprinkler and duct, interior framing, all of that. Now, what's really cool is this is not just like a set of activities that need to be done in sequence. This is where you ask people what they need and make sure they have it. So when we plan traditionally, you might ask someone how long it will take you to do the formwork here. They might tell, or the rebar. They might tell you it's 3 days. You go on site and we'll see that in managed piece, it might take 10 days. And you're like, hey, you told me it took 3 days. Why is it taking 10 days? They're like, yeah, my estimate of 3 days was correct. However, I assumed that this tower crane would be available to me. However, I've went on site and I keep calling the operator and he's busy with someone else and I've never been able to get to reach him or her. And then the 3 days turned into 10 days. Now, what we do in the recipes is we ask everyone, what do you need? How much do you need it for? And how many of it do you need? So here we're asking someone like, okay, you need 8 hours, but you also need one of these 3 cranes. You also need the material to be available. You also need equipment or anything you can put in here. So when you're scheduling with Alice, when the AI goes, it puts activities in such a way that no one who needs the crane on any given time is scheduled to go there and then the crane is not available to them. So it makes sure that they're not fighting on site to who can call this guy first and who can get the material there first. They just have it available to them. That's the big piece of what we use the AI piece for.
So I suppose thinking back to my days working in manufacturing, it's a kind of a fundamental capacity resource planning view where actually you have those finite resources. You need to schedule the availability and understand who needs them for which period of time and make sure that you have that kind of linearity where there's no, it's like clash detection in a sort of a BIM sense, isn't it?
Spot on. That's exactly it. This and the different sequences in which that those rules can be satisfied is essentially what Alice is doing.
And can you set any other kind of external dependencies? I'm thinking things like supply chain limitations or even arguably trying not to predict the weather, but can you kind of model those kind of externalities as well?
Yeah. So there's a bunch of stuff we've modeled successfully, and there's also some stuff that we haven't done yet. And as people request them more, we might build them into the product. So the cranes piece was there. So the cranes piece is like based on the radius, it detects what can be used and the reach, and etc. So this was added based on customer feedback.
Oh,
For
right, yeah.
infrastructure, we've added something called the adjacency constraint. So if you're building a bridge, if you're building a building, you might tell it might be okay to build this, then jump over here, then jump over there, as long as it gives you a more efficient schedule. But if you're building a bridge, you're not gonna start on one piece, then jump all the way to the end, then jump back to the center. It doesn't make sense. So we've built something called the adjacency constraint that recognizes pieces that are closer to each other and make sure it prioritizes. So like if you're building 1, 2, 3, 4, 5, the 3 can only be built if 2 or 4 are built, like if an element on the adjacent side of it is built. We've added other constraints like that also, like the external links. So for example, for slabs, maybe you need to form, rebar, pour, cure, and strip, but sometimes you can actually, after you pour, you can move on to the next element while it still cures, but strip will still block the schedule because it releases a formwork that is needed somewhere else. So based on how many pieces of formwork you have, it will change the whole hopscotching sequence. I've also worked on a project that was really interesting, and I'll get to procurement in a bit, where they had to move people around. So it was a facade renovation where people who had desks adjacent to the facade had to be moved to temporary offices and then brought back. And there was a limited number of temporary offices. And
All
we
right.
needed to find the most efficient way to do this. Now, people are not materials, but we don't have this modeling piece in Alice, but we do have a piece to model materials. So I modeled people as materials with each supply activity, with each demolition activity taking away a piece requiring a material, and each reconstruct activity supplying back that material, and then we'd have a limited amount of temporary offices that is the limited amount of the material. So in a way, we treated those people like we did treat the parking spaces for the concrete trucks. It sounds a little bit weird, but it does work and it gives us good results. Um,
Well, I
and
suppose
then
effectively that they are a resource that has constraints, and I suppose you call it materials, but it's a resource that you can model in that way, isn't it?
exactly. So we've had a lot of creative ways where people use Alice to model things we hadn't thought about before, but we've provided them all of the tools to be able to do that successfully.
And how about interoperability? I mean, you talked about exporting to P6 as an example, but how can you make sure that if you're in a kind of broader common data environment, that Alice can sit as part of that, and that data can flow in both directions potentially?
Yeah. So interoperability and what we do goes in two main directions. Is interoperability with the 3D modeling systems, because we're kind of marrying those two worlds of 3D design and planning and scheduling. And for that, we import from Navisworks, and we have plans to expand. But sorry, Navisworks is interoperable with most of the 3D systems out there. So we've rarely had issues with being able to get a model into Alice, unless it's like a really huge model that usually typically is not used for planning. Then we'd simplify it a bit and import it, or use 2D. And then there's the interoperability with scheduling systems. So you've worked so hard on this schedule, but your contract requires that you submit a P6, or you like to do some extra analytics that we don't show in Alice. So we have two main exports. One is the P6. This is like the industry standard. It's very customizable. So if you model P6 using resources or using activity codes, we give you the option to do both. If you prefer to use activity codes over UDFs, or costs as resources or costs as expenses, we provide you the option. Or if you like to do resource leveling in P6, we provide you the option to remove resource logic. So it's very customizable, but also we have the CSV. So the CSV is like Excel data dump.
Yeah.
You open it the first time, it might look overwhelming. There's so much, but we've given you all of the data there so that you could practically rebuild anything you want based on that data outside of Alice.
Exactly. And in terms of kind of suitability for either size or types of projects, what's the best fit? And are there any kind of edge cases where you still find it challenging to deploy Alice?
So I'm showing here a commercial building, like a medical establishment, but we've had a lot of success recently. Most of the like headline successes, I guess, with the infrastructure segment. So
Mm.
roads, highways, bridges, airports, all of that stuff. Um, but we still love working with the commercial sector. But realistically, it probably has to be a project above 50 to 70 million for it to
Mm.
be worth um, going through the effort of uh, bringing in the rules, implementing a new technology, bringing everyone on board, because a big portion of the success depends on bringing people on board internally. So if one user is using Alice and getting all these amazing results and no one else is seeing it, you're not really gonna get benefit. And that's where like our customer success team helps a lot with the organization change piece of it.
I mean, have you seen it? Because as you say, it's a bit of a cliche once again, but often, introduction and adoption of technology can bump into these people issues, to put it very bluntly. Have you seen instances of resistance to this? Are people concerned that it's in some respects de-skilling their role, or are they seeing it as a positive augmentation of what they can do rather than a threat?
Yeah, when you talk about artificial intelligence, people always think of the de-skilling or job security. Uh, Honestly, in my experience, I've not seen that a lot. I've seen resistance a lot,
Mm.
but most of the resistance comes from not wanting to do something new or not wanting to learn something. Or like I've literally heard a guy from my previous role, we were trying to implement a technology. He said like, "Hey man, I'm retiring in 2 years. I don't care what you're doing. I'm not gonna change what I'm doing." Right? So there's always that kind of person, and that's where we get most of the resistance. And that the like I don't want to pretend like we're the most amazing at overcoming this, but what I've seen that works at overcoming this is just going slow, not trying to take on too
Mm.
much. Like Alice can solve problems in pre-construction, and in a bit we'll talk about how Alice can solve problems during the construction phase,
Mm.
which is where most of the value comes from. And even though I just said where most of the value comes from, I rarely recommend for a company to start with that piece. I would say get a few successful projects in maybe trying to win bids, then get a few successful projects solving pre-construction, then get a few successful projects with the manage piece, like the project controls piece, because even if a technology sounds amazing, you gotta implement it step by step to be able to get success and lock it in.
So talk us through the value piece in the construction phase then.
Well, there's two sides of it, and this might sound a little bit controversial for the construction experts listening. So a lot of people say that a schedule is only good for 2 weeks because you have a schedule, construction starts, things go not as planned, you've slipped off the schedule, then you have a person in the office building a schedule and trying to match construction, and then a superintendent on site making up the schedule on their own, and you have these two different schedules and they diverge, and it's a big mess.
Mm.
Like we've consulted on a project where we wanted to implement Alice halfway through. We asked them, okay, what have you finished so far? And we couldn't get an answer. No one knew what's done and what's not because the information was scattered everywhere. So this is very true. Very rarely you have a construction schedule that is followed for more than
Mm.
a few weeks before it has to change. Now, what's the controversial part is there's two pieces of why it wouldn't be followed. One piece is because you have changes you cannot control. The concrete
Mm.
truck arrives on site, you measure the temperature, it failed inspection, you have to return the concrete because it's not safe to build with that, and you have to unfortunately wait for the next day. Or there's a labor union strike or anything that you cannot
Mm.
really predict. These changes are very valid, but a lot of changes are also happening because you didn't build a correct schedule in the first place. You built a schedule where it guided two people to go in the same place at the same time, and there's not
Mm.
enough space for them to work. So by using Alice, you've already covered all of the pieces of not building a schedule that accounts for the needs of every team. So you already went over that piece. So you will have definitely less changes, but still you will have the changes of all of these things we can't control, and that's where the manage piece kicks in. Once you have a schedule you like from these, you pick it and you say that is the one I want to take to manage. Then you can, as you're building your project, for each activity say like this one was completed, it was completed on time, we spent more hours than you. So you're collecting all of that data, and there's two sides of it. There's a side where Alice gives you analytics. So the recipes we built earlier were based on estimates, but now I can check for each operation what is the estimate compared to the actual, and should I go back and update those estimates? So you told me that closed forms would take 60 hours, however, it has been taking 80, but then there was a learning curve and we stabilized, so it's fine. However, rebar also stabilized, it's fine. Let's pick another example, excavation. It's always taking us longer. Is it worth going to update the estimates so that we can plan accordingly? And then the other piece is reschedule versus resequence. So when you add these progress, this is really cool. If you have a schedule that where some activities are delayed and some other activities are early, so you've completed 10 activities, 5 of them were delayed, 3 of them were on time, 2 of them were early. So now in construction, when you reschedule in P6 or any other system, especially if those activities are on the critical path, the schedule will get pushed. So if you've completed 5 activities late and 2 activities early, we don't care that you completed the activities early. The late activities are going to push everything. With Alice, you can still have that if you care about having the same schedule that you've agreed to. Or you can test resequencing. So because Alice knows the rules, Alice can leverage the activities that completed early. And several times I've seen it where you've completed 5 activities late and 2 activities early. Alice rebuilds a sequence that takes advantage of those activities that finished early and can sometimes build a schedule that was faster than the original schedule because it's taking advantage of those activities that finished early. So it's really cool. I don't recommend that you use it all the time because there is a cost of changing the commitments. If you tell, hey, we agreed to build it that way, but now we're going to build it that other way. But people ask me, oh, so should I reschedule once every week and then resequence once every 3 months so that we kind of balance it? And I will be like, sounds good, but it costs you nothing to analyze it every week in Alice. So every week you can see if it's worth it to reschedule or resequence, and then you can decide if you want to do this or not.
And presumably, Mazen, you have the same ability where, as bedevils so many construction projects, you get a design change, you get a variation. Presumably, you can remodel that effect on the schedule.
Yeah, of course, that's a big piece of construction. So this could manifest in sometimes the model changing. So they've added a floor, definitely you need to update. Sometimes it's things like they've swapped this piece of material for that other one. In those cases, even though the model updates, I usually don't update the model and I just go and change the recipes accordingly because this is a simplified model anyway, so you don't have to overdo it, right? But a lot of times they add things that, like, you add 2 floors. Well, okay, we have to update the model. Alice will retain the work you've done on the previous iteration, but you will have to make sure that the new elements are assigned the correct recipes and so on.
Well, this has been fascinating. Have we missed anything?
Oh, there's a lot to talk about. I don't know how there's a quick thing I can maybe end with is a constraint we built specifically for an airport project right before the pandemic hit. And it's proven to be very valuable for the pandemic. It's to specify how many people are in each crew. So we have 5 carpenter crews, but each crew has 4 people. We have 4 concrete crews, but each crew has 5 people. 5 steel crews, but each crew has 3. And then you can limit the number of people allowable on site. So Alice will make sure that you never have more than 60 people on site due to COVID, for example, using combinations of these crews that have different amounts of people. And it's really, really fascinating to see how that works.
Well, I suppose it's a sad instance of technology helping, but as you say, it's been such a critical thing to understand how many people you have on site at one time, and if you have some as you say, some new limitation. Well, this has been fascinating, and thanks so much for your time and walking us through what I think is a tremendously powerful example of AI helping people, not replacing them, but helping them, and ultimately delivering huge projects more efficiently and hopefully more cheaply as well. So for today, just once again, thanks so much and been great to talk.
Oh, thank you so much for this opportunity.